Welcome back, everybody. In today's video, we are going to do something a little bit different. I have not totally abandoned reinforcement learning content. However, I do want to branch out and include other stuff that happens to interest me as well, and hopefully it interests you too. So today we're going to get a very basic crash course in the topic of encryption. We are going to learn three very basic ciphers. We're going to learn the Caesar cipher, the Vignere cipher, and I hope I'm pronouncing that correctly, and the one-time pad cipher. All are very easy, and by the end of this tutorial you will be a master in implementing these in Python. So the most basic of these is the Caesar cipher. All we're going to be doing is shifting our plain text letters by some fixed amount. So if we're going to shift by 1, A will move to B will move to C, and Z will move to A. Now, the shift doesn't have to be 1. It can be a variable that we pass in to our function. And of course, to decrypt, just negative shift the ciphertext back. Now, this is obviously not something employed in the real world. This is just the most simple and basic type of encryption. The next level of encryption is something called the Vignere cipher, and this is a little bit more complicated. So this is defined in terms of something called a tabula recta, and that's a table that defines our encryption. And I've gotten this from the link here below. I hope you can see that. I recommend you check that out. It's a very good written description of the topic. The basic idea is that we have a table that has A through Z along both the row and first column, and then each successive row, the letters are shifted by 1. So for instance, in the row B, we go from B all the way to Z, and then starts over again at A, because we have a fixed 26 characters in each row and column. Similarly, for the row beginning with C, it goes from C all the way to Z, and then begins with A, B at the end. And that continues all the way down to the bottom row that starts with Z, goes all the way and starts over with A and goes all the way through Y. And the columns do the exact same thing. So the Vignere cipher relies on the use of a secret key that obviously must be kept secret, otherwise the encryption can be broken. What we're going to do is we're going to find the row with the first letter of our key, and then we're going to find the column with the first letter of our source or plain text message. The intersection of those two gives our cipher character. So for instance, let's suppose our key starts with the letter B, the source starts with the letter I, then the intersection of those two rows that row and column gives us a cipher character of J. And then we would do the same thing for the second character of the key and the second character of the source. Now, of course, this assumes that the key and the source material are the exact same length. That's very important. We'll have to implement that in code. Now, decryption is also relatively straightforward. We're going to basically be doing the reverse of the encryption process. We're going to find the row with the first letter of our key, then find the first cipher character in that row, and then move up to the column name to get the plain text. So for instance, again, our key starts with B, our cipher starts with J, then that gives the intersection column of I. So it's just the opposite, the inverse operation of the encryption. Now, the one-time pad is relatively basic, but also completely unbreakable if done correctly, and there's a whole lot of caveats on that, of course. Once again, our random key is going to be the same length as our message. We're going to physically transmit that pad to a recipient or send it over the internet in some secure channel, though I wouldn't recommend that. Then we send the message separately. So what we're going to do is something similar to the Vignere table, where we're going to iterate over the characters in our message and our key, and we're going to add those two together. So we're going to end up with some mathematical operation where we add one character to another and get another character within our alphabet. So we're doing alphabet math. You can also do a modulus or some other operation, though I've just kept it simple with addition for the purposes of this tutorial. Now, very important for the encryption security is you must destroy the pad when finished, and you must never ever reuse a key, because if you do, people can find patterns that can help them to apply some statistics to get a better idea what the original message read. And all of this stuff, we're going to have some very common code. We're going to need a character generator, which honestly I had to get off Stack Overflow because it's not so simple as it might sound. We're going to need our alphabet, which will include lowercase, uppercase letters, as well as all the punctuation. And we're going to need a function to generate a random key. And then we're going to have 3 separate files for each of those 3 encryption methods. All right, let's head to the terminal and get started. So we're going to begin with our common utilities. The only import we're going to need for this is random for our random character generator. Oh, one other thing I didn't stipulate in the brief lecture is that our secret key must be totally random, and by which I mean actually random. So that's actually very, very difficult to do, and the Python random number generator does not qualify. It is a pseudo-random number generator, so don't use any of this stuff thinking you're going to be sweet with some encryption, because you're not. So our first function is our character generator, and what this is going to do is it's going to generate a list of all the characters within some range, because I don't want to type out A through Z and then A through Z again in uppercase and then all the punctuation. So what we're going to do is we're going to write a function, and I got this off Stack Overflow. I'll leave a link to it in the GitHub. And that'll include a start character and a stop character, and it will be inclusive of the stop character. So we're going to say for char in range ord start char ord stop char +1 yield chr char. So what this is going to do is it's going to find the Unicode representation of your string, so the lowercase letter a, and the Unicode representation of the final character, let's say like Z, and generate a range over that, and it's going to yield the character representation of that number. So it's going to give you an integer generator and then convert those integers into a character. Pretty straightforward stuff. Cool little function. Please note that in the Unicode representation, the lowercase and uppercase numbers are not contiguous, so you're going to have to do a shall we say, just two separate lists for it and then concatenate them. It's not a huge deal, but just something to be aware of. Then we need our function to generate a one-time pad, and we're going to use this as common to both the Vignere cipher and the one-time pad. In the Vignere cipher, they don't call it a one-time pad, but it's effectively the same thing, a sequence of random characters that's the same length as your the plain text that you're trying to encode. So we'll just reuse the function. So this will take a number of characters for the message as well as your character set as input, and we're going to return a string choice characters or blank in range and chars. Next we're going to need our alphabet, so we'll have a lowercase equals list character generator A through Z, uppercase A through capital Z, and then our punctuation, I'm just going to use a few basic ones: the period, the comma, the space, question mark, and exclamation mark. I didn't include semicolon or colon or stuff like that. You can of course expand this if you wish. Then our alphabet is going to be lowercase plus uppercase plus punctuation. One thing to keep in mind is that when you run this code, you won't get the same answer that I do because of this random function here. We're not using the same key. It's a pseudo-random number generator. Maybe at the end I'll go through and rerun this with a random seed so you guys can check your results. But that is the other caveat we have to work with. So it's unhappy about something. The number of blank lines violates the PEP guidelines, of course. All right, now we should be good. Now we can move on to our Caesar cipher. So we're only going to have a single import. We're going to import our alphabet from common. Then we're going to have our function to translate a message. I think it's going to need an extra space. Say message is the plain text key, the plain text message we're passing in, the number of characters by which to shift, and then a boolean to tell us whether or not we are encrypting or decrypting. If encrypt is false, then we are decrypting. We'll start with the new message, just a simple empty string, number of characters, length of alphabet. And then we want to iterate over our message and add the shift to each of those characters. So for character in message, the character IDX, this is going to be the index of the character in our alphabet, is alphabet. And of course we need this because we're adding numeric values, not character values. So we're going to take the position of the character and add on some integer to get another position in our array. So we'll say alphabet.index character, and if we're encrypting, then the new character index is going to be character index plus our shift modulus number of characters, because remember, it wraps around. It's sort of like quote unquote ring buffer, not really, but it wraps around, so you have to do the modulus n chars. And then if we're decrypting, then it's just the inverse operation minus shift modulus n chars. Then our new message is just going to add on alphabet sub new char idx. Then we just return that new message. Very, very simple. So we're going to use a cipher shift of 7, and then we're going to use some very simple strings to test to make sure we didn't make a mistake. So we're going to say print AB, translate the text AB, and shift it by 7 in this case. We're going to print lowercase ab, translate AB. We can also mix lowercase and uppercase to make sure we didn't make a mistake there. And the reason I chose these is because it should print out high if you shift it by 7. You get H and I for A and B respectively. So it makes it very clear if you made a mistake. So the plain text is going to be for our message. It's just something simple. This is an encrypted message. And we've got a period and a few spaces in there. Our cipher text is going to be the translation of that plain text with our cipher shift encrypting it. So print plain text cipher text, and then we're going to do the inverse operation. We're going to say original message equals translate the cipher text with our cipher shift, passing in the value of false because we want to decrypt it. And so we're going to print the cipher text and the original message. All right, let's exit out of here and run that. Oh, it's unhappy here. It says expected 2 blank lines, but only got 1. There are no other issues. Let's run Caesar. So AB goes to HI as we expect, and so this all looks perfectly good. So our encrypted message comes out as .opz something something, and then when we decrypt, we do get our original message back out. So it looks like it works for a very basic encryption. So now we're going to move on to the Vignere table, which is a little bit more complicated. We're going to have to do the function to make our table, which I'm going to step you through step by step because it's a little bit confusing. So we're going to import a couple things. Alphabet and generate one-time pad. We're going to need a function to make our Vignere table. And you know what? I'm going to do something a little crazy here. We're going to import lowercase as well because we want to start with the lowercase letters because it's for the purposes of demonstrating our table, because it's just a reduced character set and produces a less cluttered output. So we're going to need to make basically a table. So we're going to say table equals an empty list of lists times the length of lowercase. And remember, we're going to have to come back and switch lowercase to alphabet later. Then we're going to iterate over our alphabet. So for idx character in enumerate, in this case lowercase, we're going to initialize an empty row, and then we're going to say for character in alphabet, lowercase idx onward, row.append character. So that will handle the A through Z or the B through Z or C through Z or whatever. And then we're going to say for char in lowercase up to IDX. Then we're going to append on the remaining characters. Row.append char. Now maybe there's a more elegant way of doing this, but when I'm doing YouTube, I have to strike a balance between my desire for elegance in code as well as just stuff that's easy for people to understand and follow, because it is, after all, a tutorial. So if you have a more elegant solution, by all means, drop it in the comments, make a comment on GitHub or something like that. I would be happy to see it. It's just that when I'm doing this stuff, I try to make it as straightforward as possible. And we're going to set the row of our table to that particular row, and then return our table. So let's do this. We're going to say table equals make Vignere table, and then print table. And you know what? We can even, as we're stepping through the table, we can probably print that row to make sure it makes sense. We'll say print row input. Let's try this. Python Vignere. So you can see we get A through Z as we would expect, and then B through Z with A, and then C through Z with A, B tacked on to the end, and then D through Z with A, B, C tacked on. So that looks like it is correct. We can just get rid of that and then run it again. And yeah, that's why I put in the print and the input statements. But you can see that the first row is A through Z. That's also our first column. So, so you get our first row, second row. This is hard to see. I'm glad I put in the input and print statements for the first time through. But then if we go all the way down to the bottom to double check the end, we can see it goes Z and then A and then all the way through to Y. So everything seems to make sense there. We haven't made a mistake yet. So let's delete the print statement and make our interpreter happy. And we're going to get rid of the lowercase because I'm convinced it works now. So instead of lowercase, we're going to change this to alphabet. And then I guess I could have done import lowercase as alphabet, but whatever. Alphabet and then alphabet. And so I think I've changed everything. If I'd left in a lowercase, it would be barking at me. So now, excuse me, now let's write our translate message. So our function takes a message as input, a table, a one-time pad, and a boolean. Again, we have our new message. So if we're encrypting, then we're going to say for source key in zip message one time pad. The row is going to be the 0th element dot index of our key. So that'll give us the row index where the first character matches the key for a particular row. So you have this operator here, all rows 0th element. Then we'll have column equals vig table 0th element all columns dot index of the source. Our new message then is going to be the intersection of those two, vig table row column. And then we'll say if we're not encrypting, otherwise we're decrypting, for source key in zip message one time pad. Again, you could probably consolidate some of this code. Row equals vig table all rows 0th column dot index key column equals vig table row columns dot index of our source. New message plus equals 0th row for the 0th element of the whatever column. 0th row gives us the first element, and we say return new message. So then we have too much blank space and it's unhappy with something else. I haven't generated my one-time pad yet. Okay, let's do that. So we'll say message equals this is an encrypted, hopefully spelled correctly, message, and secret key equals generate one-time pad, length of message, and pass in our alphabet. So our encrypted message and then our original message goes like that. And then we want to print the reverse operation to make sure we didn't make a mistake there. Original message. Okay, moment of truth. Okay, it's happy with everything I've done. Let's try it again. And so we do get an encrypted message here with some characters as output, and then we have the reverse operation working as well. So that is the basic implementation of a Vignere table, and we have one more to go, and that is our one-time pad, and that is very, very similar. So we start with our imports. We need alphabet and the one-time pad. And we'll start with our translate function. It takes a message, a one-time pad. Let's just call it, yeah, that's fine. One-time pad, encrypt. It's true. So new message. Empty string, number of characters, length of alphabet. As I'm writing it, I think I'm just going to do for, let's say, for source key and zip message, because in my original implementation I did an enumeration and then an array reference. So let's say character IDX equals alphabet.index for the source. Our pad IDX is alphabet.index key. And if we're encrypting, then new char IDX equals char IDX plus pad IDX modulus n chars. While if not encrypting, we say new char IDX equals char IDX minus pad IDX modulus n chars. Message plus equals alphabet sub new character IDX. And of course return. Good grief. Return new message. So once again, we'll use a very simple message. This is an encrypted message. Secret key equals generate one-time pad, length of message, and alphabet. Encrypted message. Original message. All right. See if I've made any thing to make it unhappy. Syntax error from comment. Oh, I see. I did forget my import statement. Import alphabet and generate one-time pad, and that was my only mistake. Let's try that and see if we get something unhappy. Yeah, so not enough value to unpack, expected 2-0. That's the danger of doing things on the fly. One-time pad. There we go. So it does work. So it gives me an encrypted string, and then when I pass the same encrypted string, it gives me my original message back, as one would hope. Now, as I said, for this one-time pad, you could do stuff like modulus operation instead of adding. You can do all kinds of different stuff as long as the recipient knows what operation was used and has a copy of the pad as well. Everything should be good. Now, as I said, that is a very basic introduction to the fundamental concepts of encryption. These are the three most basic. In a few weeks, months, whatever, if there's interest in this series, I will do more advanced stuff to kind of really round out our education in computer science, because let's face it, the broader education you have in computer science, the better off you're going to be as an artificial intelligence developer. So if that was helpful for you, make sure to leave a like. Any questions or concerns, leave them down in the comments below, and I'll see you in the next video.